16, the best out of all those output values. But negative 1's nice and simple too. You know what? I'm gonna use this negative 1 and 13. If this is the equation, then negative 3 halves times negative 1 better be 13. It's clearly not. We are gonna have to make some adjustments, but that's just fine. Let's go ahead and make those adjustments. So negative 3 halves times negative 1 is positive 3 halves. But I need to get to 13. In this particular case, I might actually think about this decimal-wise, just because it's a little bit easier for me in my brain, since I'm not doing this with a calculator, to go from 1.5 to 13. I know I need to go up, so that's a win. Let's see, how much do I need to go up? Is it 11.5? Sounds about right, doesn't it? Yeah. So I need to go up a whole 11.5. I should check myself with another coordinate just to make sure that I have done the math correctly. I'm gonna do a shorthanded way of erasing some of my work here just by covering it up. There we go. Okay. So now if I use the one I was gonna start with, that negative 3, negative 3 halves times 2, no, sorry, times negative 3 is positive 9 halves. 9 halves, since I used a decimal here, I'm just going to go ahead and change that to a decimal as well, and 9 halves is 4.5. 4.5 plus 11.5, doing that again without a calculator, carry my 1, 4, 5, 6, so it is 16, which is exactly what I needed it to be. When I plug negative 3 into the correct equation, I should get 16 out. So this equation, a little bit complex, but not in concept, is y equals negative 3 halves x plus 11.5. I could have also used 23 halves if I wanted to for my y-intercept value. Let's look at table C now. I tell you it's linear. Not that you couldn't have analyzed that for yourself. It does have a steady slope. So y equals blank x blank. We find that slope value. I'm just going to write on my table. My x's went up 2, while my y's went up 8. It's a little bit harder to write on this. Slope equals y over x, so that makes positive 8 divided by 2, which is 4. So y equals 4x. That might be the equation. The only problem is 2 times 4, I'll show you a shorthanded way of doing this. 2 times 4 is 8. But I'm supposed to get 11. So that means I actually have to add 3. So this equation, if correct, will be y equals 4x plus 3. Let's check another point. 4 times 4 is 16, and 16 plus 3 is the 19 that we need it to be. 6 times 4 is 24 plus 3 is 27. 8 times 4 is 32 plus 3 is 35. So y equals 4x plus 3 is our equation model. Last one. If I tell you it's linear, it has a slope and a y-intercept, and we can find it. I love how I've made these different like every single time. It's good though. I am really struggling to write using this Microsoft Paint, so I apologize. Stick with me though, we got this. So first step, since I'm not given the y-intercept, is to determine the slope. Here, my x's went up a whole whopping 1, while my y's went up a whole 7. Slope equals y divided by x. My y was positive 7, while my x was positive 1. 7 over 1 is 7, so y equals 7x is the start to our equation. And it might be the equation, it might not. I should check it with a coordinate. I'm going to check 117. So that should say 17 equals 7 times 1. Well, that's obviously not true, so we do have a y-intercept value here. 7 times 1 is 7. But I need to be at 17, so that must mean I need to add 10 to make this equation work and start up 10 from the origin. I should now test some other coordinates to make sure that this equation is accurate. 2 times 7 is 14, and 14 plus 10 is 24. 3 times 7 is 21. 21 plus 10 is 31. 4 times 7 is 28, and 28 plus 10 is 38. That verifies that my model, y equals 7x plus 10, is the correct model for equation D. So here we have the same process that we did in a lot more in depth in the first video when we were just given 2 coordinates. Only this time we were given a series of values and tables. It's in essence the same skill because we break everything back down to what is the slope if it's linear. It has 1, and we find it. And then based on that slope, do we need to make adjustments to our equation? And those adjustments are our y-intercept values. Here, we didn't have to adjust our equation. It was just literally y equals 4 times x. Here, we had to add 11.5 to make our slope work for our equation. So we had a different model, y equals negative 3 halves x plus 11.5. That one was kind of tricky, really. Apologies for my miscommunication during that process. This one wasn't too bad. Nice, familiar whole numbers, and not too big either. Y equals 4x plus 3 was the model because our slope was definitely 4, and we had to add 3 to make the equation work. And then the same thing for the final equation, very similar to C. A nice whole number slope value and a nice whole number y-intercept. I do hope this has simplified the process and solidified it for you guys. And if you're ever struggling, please go back to these videos, use them as a reference, pause, rewind, go back through things, skip through that which you do not need, and just keep doing your very best. I'm very proud of all of you.